The sum of the internal angles of a polygon. We begin with a regular polygon. Let's take a pentagon, for example. We break up this pentagon into its triangles. There are 5 triangles because there are 5 sides, and each of these triangles are isosceles triangles. We know this because each red line is of equal length. So I mark them off with purple lines to indicate that they are each equal length, making each individual triangle an isosceles triangle. A full circle will make 360 degrees. As you can see, I've marked in the center of the pentagon a green circle, indicating that the tip of every red triangle added all up together will add up to 360 degrees, a full circle. One of those angles, one of those tips, say this blue one over here, is 1/5 of the full circle. 1/5 because I'm sharing 360 degrees evenly with 5 triangles. 1/5 of 360 is the same thing as 1/5 times 360 degrees, which gives us a central angle of 72 degrees. We can find the other 2 angles, which I've marked off as x, using the fact that a triangle has an internal sum of 180 degrees. And since I said this was an isosceles triangle, these 2 bottom corners are each x, each the same angle. So 2x plus 72 degrees must give me 180. After isolating x, I get that each of those angles are actually 54 degrees. But I want the angles of the pentagon, not of the triangle. So if I add 2 of those x degrees together, I get one of my pentagon angles. And it turns out that one of my pentagon angles is twice the angle x, which is 108 degrees. This means that if I add up 5 times the angle 108 degrees, I will get 540 degrees for the total sum of the internal angles of a pentagon. So let's see if there exists a relationship between the number of sides of a polygon and the sum of the internal angles of a regular polygon. So I'm going to make a table where I list off what I know. I know that a triangle has 3 sides. It has a sum of angles of 180 degrees. I know that quadrilateral has 4 sides and the angles add up to 360 degrees. And I know that a pentagon has 5 sides and the angles add up to 540 degrees. So it looks like there's a pattern. I think I've discovered the pattern. It's n, the number of sides, minus 2, all multiplied to 180 degrees. So let's try. Let's see if this works. We know that the angles of a pentagon add up to 540 degrees because 5 times 180, as we saw last slide, is 540. So let's try with n equals 5 to see if we do indeed get 540 degrees. So n equals 5 is our pentagon. 5 minus 2 times 180 is the same thing as 3 times 180, which is in fact 540 degrees, as expected. So the formula for the sum of the angles is n minus 2 times 180. So now let's see if we can work backwards. That is, if I give you one of the angles inside a regular polygon, can you find out how many sides that polygon has? So suppose you're told that a regular polygon has an internal angle of 162 degrees. Can we work backwards to find out how many sides it has? Let's begin by drawing a portion of this polygon. And let's draw one of those triangles. These triangles, which are equilateral triangles, cuts the internal angle, the one that's 162 degrees, it cuts it exactly in half, so that the inside part of that triangle is half of 162 degrees, which is 81 degrees. But because this is an isosceles triangle, there's another 81 degrees on the opposite corner. So there's actually 81 degrees inside this triangle. If I add up all the angles of this triangle, 81 plus my unknown angle x should give me 180 degrees. I can solve for x this way, and it tells me that the central angle of this triangle is 18 degrees. The question that I have to ask myself now is, how many of these triangles must there be so that they each have a central angle of 18 degrees? How many triangles must I share 360 degrees to get 18 degrees in each upper tip? The formula that I will use is 360 degrees shared n times equals 18. When I cross multiply, I see that n, which is the number of sides and also the number of triangles, n must be 20. So there must be 20 sides in this polygon in order for the central angle to be 18 degrees. And central angle is 18 degrees because each of the interior angles of this polygon is 162 degrees.